everyone. We're going to evaluate the integral given, and we're using trigonomic substitutions with inverse substitution. So basically what I mean by inverse substitution, we're using our these substitutions, and if you look at this square root part, it has this form. So our substitution is going to be x, let x equal, you take the square root of 16, because you see these a's here. So square root of 16 is 4, so you're going to write 4 secant of theta. Now, our interval it's either going to be, we're going to deal with quadrant 1 or quadrant 3, and we'll be using this identity. So our derivative of x is going to be 4 secant theta tan theta d theta. Now what I want to look at is just this portion here. So when you substitute for t, basically we don't want to let it be, well, let's just substitute. So we're going to have, instead of x, we should have really called this t. So let's let this be t. So t dt. Sorry about that. So now let's substitute in just this part. You'll get t squared minus 16 equals, and square this. So that's going to give you 16 secant squared theta minus 16. And that's going to give you square root. If you pull out the 16, that's going to be secant squared minus 1. So that's going to be, pull out that 4. Secant squared minus 1 is tan squared. All right, and then that's going to equal 4 absolute value of tan of theta. But tan is positive in both quadrants 1 and 3. So we can take away the absolute value sign. So that's going to be the denominator. So now let's fill everything in with our integral here. So we know dt, so that's your numerator. That's going to be 4 secant theta tan theta d theta divided by t squared, so square this, and that's going to be 16 secant squared theta, and then square root of t squared minus 16 is 4 tan of theta, so that's times 4 tan of theta. Now all we have to do from here is simplify. These 4's cancel, so I'm going to bring out this 1/16, and the tans cancel, and then we're just going to get 1 divided by secant of theta d theta, which equals 1 divided by 16th cosine of theta d theta. So if you integrate that, you're going to get, this is from here, 1/16 sine theta plus c. The problem is we started with x, and we're with ending with theta. So what we want to do is, okay, let me write it again. We have 1/16 sine of theta plus c. You draw a right triangle, and we let x, or t, we let t equal 4 secant of theta. That means secant of theta equals t divided by 4. And remember, secant is basically r divided by adjacent. So here's your theta. There's your right angle right there. So r is your t. Your adjacent is going to be 4. And then you use the Pythagorean theorem. 4 squared, we'll just call it y squared. We'll call this y for now. Y squared equals t squared. So to solve for this, you're just going to get solve for y equals square root of t squared minus 16. So this just equals square root of t squared minus 16, which is basically what we started with in the original. So now we have to deal with sine. So we have 1/16, and we want sine of theta. Well, sine is opposite over hypothesis. So opposite is going to be square root of t squared minus 16, and your radius or your hypotenuse is t plus c. Or you could just write it as t squared minus 16 divided by 16t plus c. And that's it. Thank you. Have a nice day. Bye-bye.